Yeah. So, hi, Professor. The paper which I was chosen was titled as "Rethinking Model Inversion Attacks Against Deep Neural Networks." This paper was actually published on CVPR Conference 2023, and the following are the authors of the paper. Starting with the introduction of the paper, this paper actually addresses the privacy concerns of deep neural networks, which have been used in many domains in the industry. The focus is on model inversion attacks, which aim to reconstruct the features of the data sets which we are going to use in our models. For example, so let's imagine we have a model of where we doing the face recognition, and we are using different images for the training data set, and there's attack on the model, and which will reconstruct the images of people which we're using in the data set. So this is a solid example of inversion attacks on the deep neural network models. So the author actually reviews the state of the art inversion attacks which have been extended to complex networks. Despite the range of approaches proposed in the recent works, all these approaches involve an optimization inversion step which formulates the construction of training samples, which is same for all the models. The main objectives of the model includes revisiting the state of the art membership inference, starting two major issues to all the models and proposing solutions which are complementary. So the two major terms which are used in the proposed solutions are inversion step and identity loss. Inversion step is actually common for all the models. So the optimization objective involves the identity loss, which is also same, and that is formulated using the negative log likelihood. So for the samples that we have reconstructed under the attack model, this paper highlights the need for effective design of identity loss, which we going to form for use. We're going to calculate using different formulas, which we will cover in the methods slide. So which is here. So the inversion step is actually share a common step for all the models, which optimizes the identity loss, guiding the reconstruction of samples most likely to be recognized by the model. So the identity loss is actually, despite advances in improving the prior loss, the design of a more effective lid has been overlooked. This focus on analyzing and improving the LID, leading to the performance boost. So the identity loss is formulated using the following formula, which can be formulated, which results in the improved performance of the attack accuracy. So we will actually compute the identity loss in the model augmentation also. Also, like one of the major issue which the authors have been seen was the overfitting issue. The mod inversion has an overfitting issue which arises when the images fail to learn the semantics from training data, which leading to poor attack performance, which can be overcome or resolved using the model augmentation idea, which uses this identity loss to improve the quality of the reconstructed images. These methods together lead to a significant boost in the performance of all all state of the art inversion attacks. The key contributions which was described in the paper was analyzing the two different issues and proposing the improved optimization objective that significantly boosts the attack performance, and also proposing the model augmentation idea which resolves the overfitting issue. So coming to the one of the key contribution which was mentioned in the paper was the improving the attack accuracy. So one of the example was, for instance, in the celeb benchmark, the solutions have increased in accuracy of 11.8%, which is result in overall accuracy of 90%, which was good. These findings of the paper demonstrates a clear risk of leaking sensitive information from different models, which has to be taken care of. So the experimental setup has been done in the following way. This has been done with different approaches so that we can have the fake comparison, which is available on different models like face recognition, digit recognition, image classification. On different models, the experiments has been done. So the data set is been split into two parts, private and public. So the public has been used to access the private information, and the public has no interaction with the private. So various complexities are implemented for face recognition. These were used and for digit classification. Two pooling layers have been used, and the evaluation metrics we use was attack accuracy and the k nearest neighbor distance. So the results of the experimental are these. So they are actually compared with these baselines, and three variants have been used, which involve replacing the existing loss with improved versions. So the improved attack accuracy has been shown with the results. The cross data set experiments are also done in order to understand the effect of distribution shift between public and private data. So the conclusion of the paper, or the summary of the paper, includes revisiting the state of the art and improving the identity loss by formulating the new formula, which we have done in the model augmentation step, and addressing the overfitting issue, which was resolved using the data augmentation, which uses actually the identity loss. A new logic based identity loss is proposed, which aligns with the goal. So extensive experiments demonstrate that a proposed solution significantly improve model attacks, achieving over 90% accuracy under the benchmarks. This highlights the rising threats based on the attacks and the need for serious consideration of privacy in different AI models. Thank you.